Heidi ho, everybody. We are going to look at 4-2 today, which is our second lesson in topic 4. And we're going to look, this whole lesson is all about isosceles triangles, which are triangles that have two of the sides are the same, and equilateral triangles, which are triangles where all three sides are the same. So by the end of this lesson, you should be able to use properties and theorems about these triangles to solve problems. And then identify congruent triangles by using properties of isosceles and equilateral triangles. So not only do we have to define what is an equilateral triangle and an isosceles triangle, but then we have the isosceles triangle theorem, the converse of the isosceles triangle theorem, and then the angle bisector of an isosceles triangle theorem. So kind of 5 things to review there. So we're going to jump down to the back of your packet where those terms are. And we're going to start there by going through our terms. All right, so here we are on our terms page. And the first term that we're going to look at is an equilateral triangle. And this just, oh, my pen's a little jumpy. There we go. This is just a triangle with 3 congruent sides. So I'll do my very best on drawing a triangle here. Okay, so if I label this triangle A, B, C, all this means is that all 3 sides are the same length. So I can put those tick marks there. Another really important feature of an isosceles an equilateral triangle is that all 3 angles are also the same. Okay, so it's not only a triangle with 3 congruent sides, it's also a triangle with 3 congruent angles. So all 3 sides are the same length, all 3 angles are the same angle measured. Okay. The next one is an isosceles triangle. So this happens, and again, I'm going to label it here. So this is a triangle with 2 congruent sides. So it's usually these upper ones, but it doesn't always have to be. Okay, 2 of the sides are the same. And whatever sides are the same, those are the angles that are also the same. So as those sides approach your base, okay, these are called base angles. So 2 congruent sides, but it's also a triangle with 2 congruent. And instead of just angles, I'm going to write base angles because it's important that we know what they're called. Base angles. Those are our 2 definitions for today. So nothing hopefully super shocking here. Hopefully we know what an equilateral triangle is and we know what an isosceles triangle is. So I'm going to clear this and then let's go down and we're going to talk about our theorems, postulates. Okay, so we have 3 of these to go over today. The first one is the isosceles triangle theorem. And what this says is if 2 sides of a triangle are congruent, then the angles opposite those sides are congruent. So that's what we just wrote down. It looks more like an equilateral triangle, but it's okay. We can manage A, B, C. So what it's saying is if 2 sides of a triangle are congruent, the angle's opposite. So the angle opposite of AB is angle C. And the angle opposite, right, across from BC is A. So this just tells me that angle A is congruent to angle C. Okay? So if these 2 side lengths are the same, then these two angles are the same. That's what it's saying. The converse is just going the opposite way. So here's my triangle again. A, B, C. So the converse is saying, hey, if these two angles are the same, right? So if all I know about this triangle is that these two angles are the same, then I can go ahead and say that the sides are congruent. So I can say if angle A is congruent to angle, C, then AB, so line segment, and then it's a line segment because the line above it is congruent to CB. Okay, so this is saying if the angles are equal, then the sides are equal. This one is saying if the side, I should say, if the sides are equal, so if AB is congruent to CB, then angle A is congruent to angle C. So they're just going opposite ways. This one says if the two sides are congruent, then the angles are congruent. This one says if the angles are congruent, then the two sides are congruent. And then the last one is the angle bisector of an isosceles triangle. So I'm going to draw an isosceles triangle here, more or less. A, B, C. Okay. If a line or line segment bisects the vertex angle of an isosceles triangle, so I can make that be better. So I'm going to bisect this angle, meaning I'm going to cut this angle in half. So if I draw a line that cuts that angle in half, there, I've drawn the line. Okay, so how do I know that it's cut the angle in half? Because this angle and this angle are the same. Okay, these two angles are the same. And I'm going to draw that a little bit differently so that we don't get confused because it kind of just looked like one big angle, didn't it? So this angle and this angle are the same. Okay? Because it bisects the vertical angle. Okay? So if a line or line segment bisects the vertical angle, okay, it's done that, then of an isosceles triangle, so again, these have to be equal, and these have to be equal, then it is also the perpendicular bisector of the opposite side. So let's look at this. Perpendicular, meaning it crosses the other side at 90 degrees, and it bisects it, it cuts it in half. So this length, let's call this point D. So from A to D and from C to D is the same distance. It's the same distance. So if angle ABD, right here, ABD, this guy right here. So if that is congruent to angle CBD, so from C to B to D, so this angle, okay, then I can say that line segment AD, so this length right here with two tick marks, is congruent to line segment CD. So if this bisects an isosceles triangle, so if these two angles are equal, then I know that AD and CD are the same length. And so these three properties are something that we're going to be using pretty heavily in this lesson to kind of help us figure out what angle measures are in these triangles. So once you have all this written down, we're going to go back to the lesson and we're going to look at how can we use these properties to help us solve problems. All right, so let's look at example 1 here. And example 1 says, how are the base angles of an isosceles triangle related? So if I draw myself an isosceles triangle, so isosceles means, oh no, we should always label our triangles. So isosceles just means that the two sides are the same length. So how are these base angles related? Okay, and so hopefully we can tell, and we just talked about it, that angle BAC, which is this angle right here, right, B to A to C, is congruent to angle BCA, which is BCA. So that's this angle. Okay, so the two base angles, sorry, my pin's a little jumpy today. The two base angles are congruent. They are the same. Okay, so we're going to use that property to help us solve a bunch of different problems here. So let's look at the first one, which is this word problem. Okay, it says an architect is designing a community park between North 1st Street and South 1st Street. So here's the park. The pathway on either side of the pool will be equal in length. So this tells me I'm going to go ahead and draw this as a separate triangle that maybe is a little bit easier for us to understand. So the pathways along South 1st Street and North 1st Street are going to be the same. Okay, so this is point D. Sorry, my dog's barking. E. This is point F. We're just going to ignore it. It's fine. Maybe I should go see. Hold on. Okay, she's just going to keep barking. Okay, and then this is 50, just because it says right here, okay? So it says the pathways on either side of the pool will be equal in length. That's how I knew I could put these tick marks here. To protect the landscaping and to minimize erosion, the architect will place a triangular section of triangular cobblestones along the corner along Park Plaza. What angle measures should the architect specify for the corners? So really it's asking me, what is this angle? What is that angle? And what is this angle? Okay, and I don't know what they are. But because this is an isosceles triangle, I do know that they are the same. Okay, right? Because the angle across from each side, or across from the two sides that are equal, are the same. So if I don't know what this is, I can call it X. But then this is also X because those two base angles are always the same measure. So now I have information about all three angles, and all three angles of a triangle add to 180. So I can add this up. I can say that 50 plus X equals 180. Right? 50 plus X plus X. Just adding up all three angles and setting it equal to 180. So I have 50 plus 2X equals 180. I just combined X plus X. Now I'm going to subtract 50 to both sides, right? Because I want to solve. I get 2X is equal to 130. Divide by 2. Divide by 2. And I get X is equal to 65 degrees. Okay, so that's the angle measure that the architect should specify for the corners. That tells me that both of these angles So that tells me this is 65, and that tells me that this is 65. And how could you check your work? Add up all three angles and make sure that they add to 180. Because if they don't, then something happened and you probably did something wrong. Okay, so hopefully that makes sense. Just keeping in mind those two base angles are always the same, and that's the key in these problems, okay? So here we have a couple triads. I'm going to go through one of them with you. So I'm going to do A with you, and then you're going to try B, and you're also going to try this second triad, okay? But let's look at A. A says, what is the value of x in the following figures? Well, here's my two sides that are equal. So this is a base angle and this is a base angle. My base angles are the same. So if this angle is 28, then that means this angle is also 28. So hopefully that makes sense how we got that. And then I know that the three angles of a triangle add to 180. So 28 plus 28 plus 5x plus 9 equals 180. And we can combine all of our like terms. 28 plus 9 is 65. So the 5x comes down and I get 65. So I just did 28 plus 9. We can subtract 65. 5x equals 115. And then a quick division by 5. And I get x equals 23. So go ahead and hit pause on the video, try part B, try the second triad, and then when you're ready, go ahead and hit play. All right, so let's go over these problems that we did. So hopefully here we see this is an isosceles triangle because I have two sides that are congruent. Therefore, these two base angles are congruent. So I can say that negative 4x plus 9 is the same as 8x minus 3. And now I'm just going to solve for x, okay? So plus 4x plus 4x. I'm left with 9 equals 12x. Minus 3, not plus 3. Minus 3. Okay, I'm going to add 3 to both sides. And I get 12 is equal to 12x. Divide by 12, divide by 12, x equals 1. And on this problem, it's just asking us what is the value of x, so I don't have to go any further. Okay. The other one that I wanted you guys to try, let's review that. This says in triangle ABC, the measure of angle A is 24. So this right here is 24. What is the measure of B and what is the measure of C? Well, because this is an isosceles triangle, I know that B and C are the same. They're both, let's say, x. So I can write that 24 plus x is equal to 180, right? Those three angles add up to 180. I'm going to subtract 24 to both sides. And I get x plus x, which is 2x, equals 156. Okay, we can divide both sides by 2, and x equals 78. However, in this problem, it's not asking us what is x, right? It's asking us what is the measure of angle B. So the measure of angle B equals x. Well, x is 78. So the measure of angle B is 78 degrees. And it's asking us for C as well. The measure of angle C is also 78 degrees. So you want to make sure that you pay attention to what is the question asking me to find, right? It's not always just asking you to find x. Okay, so hopefully we feel good about recognizing if those two sides are congruent, then the two base angles are congruent. What we're going to look at next is just going the opposite way. If the base angles are congruent, then the sides are congruent. So looking here, it says, what are the lengths of all three sides of the triangle? So let's look. I see that angle P and angle Q are the same. And so if angle P and Q are the same, that automatically means that PR and QR are the same length. So that tells me that x plus 20 is equal to 8x over 3. Right? Those two side lengths are the same. Now, I really don't like that there's a fraction going on here, right? It just makes it look messy, and I don't like it. So I'm going to multiply both sides by 3. When I do that, I end up having to multiply both of those things by 3, so just make sure you're paying attention there. These 3's get to cancel, right? 3 on top, 3 on bottom. So 3 times x is 3x. 3 times 20 is 60. These 3's canceled, so I'm just left with 8x. So what I've allowed myself to do is I've allowed myself to get rid of the fraction and just make it a little bit easier to solve. So we can subtract 3x to both sides. I get 60 equals 5x. Divide by 5, divide by 5. 12 equals x. And that's great, but that's not what it's asking me to find, right? It wants the length of all three sides. So I'm going to have to take my x and plug it back in. So this is going to be 6 times 12 minus 12. So when I do that, I get that the length of PQ is 60. Okay. Here, if I plug in 12, I get 12 plus 20. So I get that PR is equal to 32. And then over here, I have 8 times 12 divided by 3, right? And I get that QR is also 32, which makes sense, right? Because this length and this length are the same, so they should both be 32. Okay, so just using that information then to help us figure out what the length of all the sides are. Okay, so there's a couple try-its here that you guys are going to give a good old college try to. Okay, here's the first one. So I want you to pause the video, do this one, and then when you're ready to go over it, go ahead and hit play, and then we'll talk about the next one. All right, so hopefully we gave this a shot here. It says use the figure shown. What is the value of x? Well, since these two angles are the same, these two side lengths are the same, so I can just set them equal to each other. So 8x minus 1 equals 4x plus 5. Let's subtract 4x. And I get 4x minus 1 equals 5. Add 1, add 1. And we're out of space. 4x equals 6. Divide by 4, divide by 4. And I get x is equal to 1.5. It's okay to get a decimal. It's the value of x. Then it says, what are the lengths of all three sides? Well, I don't have vertices here, so that's okay. We're just going to plug them in. So 8 times 1.5 minus 1 is 11. So this side length is 11. 4 times 1.5 plus 5 is 6 plus 5, which is also 11. Which again makes sense, right? Because they're an isosceles triangle. And then 2 times 1.5 plus 11 is 3 plus 11, which is 14. And there's the length of all three sides. So again, reach out if you're not feeling good about that. Let's look at our next one here. The next try is find the perimeter of triangle ABC. So the perimeter just means I take all three sides and I just add them up. Okay, right? It's the distance around the whole shape, so you add up all three sides. So you're going to do exactly what you just did on the previous problem. The only difference is that you are going to add up all three sides to find the perimeter. Okay. The other thing here is I don't know that these two base angles are the same. So if I do x, right, x plus 132 plus 24 equals 180, and I solve, I get x is 24. So I can get rid of this. X is 24. Now I know that this is an isosceles triangle, so I can say that AC and BC are the same. So go ahead and do, hit pause, go ahead and do what you did on the last video, and then we'll go over it. Okay, so let's review here. Hopefully we set our two sides equal to each other. 2x plus 15 equals 4x minus 5. Subtract your 2x. I'm going to get 15 equals 2x minus 5. Add 5. Add 5. 20 equals 2x. Divide by 2. Divide by 2. We get x is equal to 10. That's great, but that's not what it's asking me to find, right? So I'm going to plug it back in. 2 times 10 is 20. 20 plus 15 is 35. So that side is 35. 4 times 10 is 40. Minus 5 is 35. Again, that makes sense, right? They should be the same because they're isosceles. And then 4 times 10 is 40. Plus 12 is 52. So if I want to find the perimeter, right? The perimeter is just the distance around the shape. So I'm going to take 35, I'm going to add 35, and I'm going to add 52. So the perimeter is equal to 122 units. So that is the total distance around. And the reason I wrote units is because I'm not given if this is inches or feet or centimeters or miles or whatever, right? I don't know what the unit is, so I'm just going to write units. Okay, so we are going to keep going here. We are going to continue, and we're going to do example 4, which is a real life problem here. So example 4 says a prefabricated house is delivered to a foundation in 2 symmetric halves that are assembled on site. So you get the whole left side of the house and the whole right side of the house delivered separately, and then they put it together. Along the planned route to the site, the truck must pass under a bridge that has a clearance height of 17 feet. Should the trucker plan a different route for delivering the house? So basically what the question is this distance right here more than or less than 17 feet? Because if this distance is more than 17 feet, the trucker's not going to fit under the bridge. But if this distance is less than 17 feet, he will fit. So what I kind of like to do is when I have problems like this, I like to kind of split up and redraw it myself in a way that makes a little bit more sense to me, right? So I'm not just looking at a house. So here's just the triangle. I know that this is 10 feet by 28 feet, so I don't really need to do anything with the base. I'm just looking up here, okay? And I have this line that's coming down, and I know that this is being split in half. I know that this is 16, and this is 16, which means this is an isosceles triangle, so this angle and this angle are the same. Okay, so now we have to go through and we have to think about if I split this angle in half, that means it bisects. And we just did a theorem on what that is, right? The angle bisector of an isosceles triangle tells me that if the angle, if I split, if I bisect my vertex angle, then this line is the perpendicular So it's perpendicular bisector. So it cuts it in half perfectly. So this distance, right, and this distance are the same length, and it's a right angle. So I'm going to draw one of these triangles. It's a right triangle. Here's A. Okay, I know that this guy is 16. Okay, no, this is 90. And then the other thing that I don't know is, well, the whole base of the house, so the whole width of the house is 28 feet. Well, a perpendicular bisector cuts that line in half. So that means that each of these is 14. So this length right here is 14. So now we can use Pythagorean's theorem to find what the height is, right? So I can use my a squared plus b squared equals c squared. Remembering that c is always the side that's across from the right angle. So a, it can either be 14 or h. It doesn't matter. I'm going to go with 14. So 14 squared plus the other side is h squared. And then my c is 16. And I'm just going to solve. 14 squared is 196 plus h squared. And this 16 squared is 256. Let's subtract 196. And I get h squared is equal to 60. And then I need to get rid of the squared. So what I'm going to do is I'm going to take the square root of both sides because that'll cancel out the squared. And I get h is about 7.75. So this distance right here is 7.75. And then this distance right here is 10. So the total distance of the house is 17.75. So then the question is, will this fit under the bridge? And the answer is no, right? The bridge is only 17 feet high, but the house is 17 feet 8 inches high. So this 8 inches too big. Okay, so should the trucker plan a different route? Yes, right? Yes. He should plan a different route. And then it says explain. So then I have to say because, right? The house is 17.75 feet tall. So the house is too tall to fit under the bridge. Okay, we have a try it now. So you guys are up. Here's your try it. It wants to know what is the angle of RSQ, which is this guy right here. And it wants what is the length of PR. Oh, sorry, PR, this full length. Okay, so go ahead and hit pause on the video, and then after you're done, you're ready to review it, hit play. All right, so let's review here. There's a couple different ways that you could have done this. Hopefully we realize that this is 31, right, because it is an isosceles triangle. And then this is the perpendicular bisector. So then that means that this angle is 90, and then this angle is also 90. So there's a couple ways you could have done it. You could have done this that 31 plus 31 plus S equals 180. and you would have gotten that S is equal to 118. But then S is split in half, so I have to divide that by 2, and I get that the measure of angle RSQ is 59 degrees. So that's one way you could have done it. The other way is noticing that this is 90, so 90 plus 31 plus, we can call it x if we want, x is equal to 180, and solve, and we also would have gotten that x is 59. So either way, you should have gotten the same answer. There's multiple ways to think about it, and I'm sure you did great. Then the last one is, what is PR? Well, since this line, SQ, is a perpendicular bisector, that means that RQ and PQ are the same length. So if RQ is 4, that means that PQ is also 4. So that means the whole length there should be 8 units. And again, I don't know what the units are. I don't know if they're feet or inches or whatever. So it's just 8 units. Almost done here. The last thing we're going to talk about is equilateral triangles. So just to review, right? Equilateral triangles, all 3 sides are the same length, and all 3 angles are the same measure. And more specific, right? If all of these are the same measure, they're all the same. So I can call them X, right? All 3 of them are X. So that tells me that X plus X plus X equals 180. So then I can solve and say 3x equals 180. Divide by 3, divide by 3, x equals 60. So not only are all 3 of the angles the same, but more specifically, all 3 of the angles are 60 degrees. And that is just a fact with with equilateral triangles. So we can automatically just fill that in when we see them. Okay, so let's look at an example here. Example 5, we're doing this one together, and then you guys have one try it. And this is a typo, so I don't know what that is. Okay, but this says if the measure of CBD is 130, so CBD, this whole thing is 130, what is BAD? So regardless of what it's asking, I'm just going to go in and fill in as much information as I can. Okay, I see that ABC is an equilateral triangle, so that tells me that this is 60. That tells me this is 60, and that tells me this is 60. Okay, so that's great. I also know that this whole angle right here is 130. So hopefully that gives us a little clue that we can say, hey, 60 plus, let's call it x, equals 130. Right? Subtract 60, and I get x is equal to 70. So that tells me now, let me get rid of all of that, that this angle is 60 and this angle is 70. Okay? Now, if I look at triangle ABD, this is an isosceles triangle. So that means that these 2 angles right here, let's call them y, those are the same, right? So y plus 70 equals 180, right? Because I'm trying to solve for this angle right here, BAD. So subtract 70, y plus y is 2y, so 2y equals 110. Divide by 2, divide by 2. So y is equal to 55 degrees. So that means this angle is 55 and this angle is 55, which is very helpful because the measure of BAD, right, is y. So the measure of angle BAD is equal to 55 degrees. So sometimes you do have to find other pieces before you can find what you're asked to find, right? I filled in everything else before I could find out what I was asked to find. So our last problem in this lesson is a try it. So if we clear this out and scroll down, very similar to the one we just did. Okay, find each angle measure in the figure. So you're going to go in and fill in all your angle measures. And then it wants you to find specifically PNO, which is this angle right here. And then NOP, which is this angle right here. So go ahead and pause the video, try it, and then when you're ready, let's go over it. Okay, so hopefully we filled in some angles here, right? I have an equilateral triangle. That tells me that all of these angles are 60. Okay, and then I see that 60 and this angle add to 180, right? Because they make a straight line. They're a linear pair. So 180 minus 60, hopefully we got that this angle is 120. And that's the first one, right? What is the measure of angle PNO? Well, in this case, it's 120. Right? P to N to O, this angle right here, 120. And then the last thing, it wants these angles. So if I call these X, right, I have X plus X, which is 2X, plus 120 equals 180. Subtract 120, and I get 2X equals 60. Divide by 2, and I get X equals 30. So that tells me that this is 30, and this is 30. So what is the measure of angle NOP? N to O to P is 30 degrees. So again, just using information that we know, start plugging in things, even if you're not sure if it's going to help you or not. Just start plugging things in, and you never know if it's right. It could be really helpful, or it could help you find something else that can be helpful. That's it for 4-2 today. Hopefully we feel good. Please, again, as always, reach out if you need help, and we'll see you later.